Hello, operations management students. It's decision tree time, and I am going to show you how to use Microsoft Excel to calculate the expected value of a decision tree. So I'm just going to flip over to the course page and show you an example. So this is a tree picture from your homework assignment, and these letters and symbols mean specific things, right? So square nodes are nodes that we decide. So this actually whole setup is kind of reminiscent of a decision to do market research or not, right? If I choose to do the market research, I spend some money, I arrive at node B. B is a circle, which means the universe decides. And what the universe is deciding here is whether the market research returns favorably, right? That this was a good possibility of being successful, or unfavorably, and it has a poor possibility of being successful. And at that point, we have a decision to make. Given the favorable market research, should we invest a lot, a little, or not invest? And given a poor market research outcome, should we invest a lot, or a little, or nothing? And given that choice, then, right, these are circles, the universe decides. It will go well, or go poorly, or go well, or go poorly, or go well, or go poorly, or go well, or go poorly. There's no nodes coming off of do nothing, because nothing would happen if we did nothing, right? Now we have that exact same setup down here where we just wing it, right? We don't do any market research, we just wing it. So all of these have different payoffs associated with them. If we predict good market outcomes, we ultimately realize those. If we do a market research, find out that the market research is good, favorable, we do a big investment and then it goes well, this is probably going to be a big payoff. But if we do the market research, find out that it's unfavorable, we invest a lot anyway, and it goes poorly, that's most likely going to be a very negative outcome. Decision tree analysis is all about deciding what's appropriate in each of these circumstances. And the key here is that when we are deciding, it's up to us to pick the best of the choices, right? So in Excel terms, that's literally tell me the maximum of all of these things and pick that, right? That will become the value of this node because we will choose the maximum outcome. Whereas when the universe decides, the universe doesn't always, right? It doesn't always turn out that the market research comes back favorable. Sometimes it's unfavorable, and there are probabilities that this happens versus probabilities that this happens. And so the universe will decide which of these two outcomes, but nevertheless, the universe will decide. But it won't be a choice based on the maximum outcome. It will be a probability-weighted result. So I'll show you how to do the math for that. But yeah, let's go ahead and get started. So we've got some information here. So I'm just going to go ahead and copy this. It's good to grab a little extra if you can. So I'm going to grab this answer down here just because then you're for sure to get the HTML text that's invisible to you, the user. It just makes pasting tends to go a little better. If you don't grab that extra text in the bottom, you might be fine. Sometimes it'll try to put it all in one cell, so you just have this really long list, and that's frustrating and unpleasant and unhelpful. So at that point, just try to copy and do it again. So we've got all of these different nodes, right? And when we do decision trees, we work our way backwards. So we are going to start with, these far right outcomes, and then work our way left because, right, for me to decide what to do in D, I need to know the value of K and L, but to know the value of K and L, I need to know the value of Q and W and the chance of getting there, right? So we work our way backwards from the future to the present to make a decision. So we're going to just start with Q and W. And so looking at my payoffs here, we have that Q this is the probability of getting to Q, and this is the payoff of Q, and this is the probability of W and the payoff of W. So I'm just going to go ahead right away and throw an equal sign in front of these so that we get the actual probability value for these nodes. It's expressed in 1 minus terms, which is not helpful for Excel. So right now I want to find the value of k. And so I'm going to make this bigger so we can see, because we're interested in this. What is the payoff of getting to k? Well, the payoff of getting to k depends on two things. It depends on the value of q and the chance of q, and the value of w and the chance of w. So these universe nodes, the circle nodes, are probability weighted averages. So it looks like this. QW, right? Chance of Q times value of Q, right? Plus chance of W times value of W. Again, chance of Q times value of Q plus chance of W times value of W. You'll see these two add up to 1, right? We got to 100% of the time you're going to be at either Q or W. And so we get this formula here. And this formula we can use more than once. So right now we just have a value of 29.6 for K. Right? Because we're working backwards, we take these two and average them out to get to K. So on average, we're happy here. Now let's do Rx and L. So I'm going to just copy and paste this into L. Now, Excel will automatically shift all the cell references down 1 square. That's not necessarily what we want to do. So I'm going to hit the F2 key. If you're on Windows, and on Mac, I'm not sure what this hotkey is. That you can also just double-click the cell. And it's checking nodes R and nodes X. So this turns out to be accurate, right? So R and X are the ones we want. I kind of set it up that way to make it a little easier for you. But yeah, it's because we want R and X, we will use R times R and probably of X times payoff of X. And we get this outcome, which is not great. It's positive, but it's not great. And then lastly, we need G. G has a value of 0, so we don't have to calculate it, right? This is just we do nothing. So we're done with these three. And so now normally, probably what we should do is move on to MN and H. But let me just demonstrate real quick how I would calculate D. So D, right, is different. D is us choose, right? So D, we're choosing between K, L, and G. So for my D, I'm going to use the Excel function max. So maximum of, and now I have some choices. So I'm going to choose K, comma, L, comma, G. And what will this do? This will return the maximum of those three values, which, we can do this by hand, by doing, eyeball. Clearly 29 is the biggest, right? So I'm going to hit enter and get 29.6 because that is the biggest value. Now we're going to do the same thing for E, right? E should depend on M, N, and H. So if I copy and paste this here, now you can see these are wrong. So H is fine, but this is pointing at the wrong thing. So I want to do M, N, and H. Let me just verify that that's true, right? M, N, and H. And that makes sense because, right, this E was 1 under D, but we had to cover 2 rows. So you can't normally just copy and paste and have it work out. You usually have to tweak. But now we're pointing at the right thing. However, right, we're not going to get the right answers yet because we haven't completed M and N. So I can hit enter, and it's going to give me an answer right now, but this answer is most likely inaccurate because we need M and N. Although these might be negative, in which case 0 is correct. So just to recap, we figured out K, we figured out L, we figured out G. G we already had, we calculated D. We've done E, so we need to do M and N is next up. And then obviously we'll do then I and J. So let's go ahead and do M, N, I, and J. decision trees always are filled with one of the two types of things, right? Either it's a circle and you're doing the probability weighted average, or it's a square and you do max, right? What if there were 9 nodes off this? Well, it's not that different. You just say max A7, comma A8, comma A9, whatever you're going to list the 9 possibilities, and it will just pick the next one. What if there were 9 nodes coming off this? Well, it would be probability times payoff plus probability times payoff plus probability times payoff, and then all those probabilities would have to sum to 1 so that it becomes a weighted average. All right, let's do M, N, I, and J. So M should be similar to L. So I'm going to go ahead and copy L and paste it in M. Now M should be used nodes S and nodes Y. So I'm going to hit F2 here. We have S and Y. We're in good shape there. So this one's fine. I'm going to paste in N. N is using T and Z, which is fine. Now let's check I and J. So copy this. Let's go back up to I. I should be using O and U. O and U, we're good. And then J should be using P and V. P and V, we're good. Okay, and then C should be using I, J, and F. So that one's unlikely to be correct right out of the box, but we'll try it. I've got scroll lock on here. And so it's doing F, J, and K. So that is incorrect. We want F, J, and I. So I'm going to move the K to I. Right? It didn't end up mattering because J is the best node. Okay, so now we've got, right, so just to recap. So we know D, if we arrive at D, right, if we arrive at D, we have a value of 29.6, right? If we arrive at C, we have a value of 61.8. If we arrive at E, we have a value of 0, right? So 29, 0, 60. So we can kind of tell already, right, that it is not going to be a good idea to do the market research. It is too expensive. We should just invest, right, and not take the time and money to do research. But we'll complete the whole process. But we can tell right now, since C is bigger than D and E, A will pick C instead of B. But we should calculate B, right? So B is dependent on D and E. So I'm going to say, we'll just do our copy again. So we need a universe node, so we'll use I. So right here. All right, now which nodes do we want to point at? We want to be pointing at D and E, so I'm going to have to move some stuff around. So this should be pointing at D, and then this should be pointing at E. And oh, right, I just noticed that, well, let me resolve this here. This needs to have an equal sign because this doesn't understand. Now, there we go. Now we probably had an error before. Yeah, it's an error if I don't fix it, but there. Yeah, B, not great, right? $20 million versus $60 million for C. So again, A chooses between these two. So A is going to do the maximum of B and C because it's a square box, right? So, and I'm just going to type it, equals max, B comes C. And we get a payoff of 61.8. And actually, if we go look, 61.8 is node J, which is the middle level of investment, right? So I is too negative. Like if you look at the U state, if things go bad, U is good, sorry. If you look at the O state when things go bad, this is really bad. Whereas if the P state is much, so basically you minimize a lot of damage by not going all in. So really, I mean, our decision tree analysis of the situation is that you can't go all in without a lot of market research. The market research is too expensive, and so it makes sense to not do expensive market research, and to do a modest investment in whatever project this is. And that's what's going to ultimately produce the best payoff. And this is not unusual, right? Because one way to explore a market is to do lots of in-depth research. Another way is to just be first mover and launch a little bit. And so you launch a modest version, and then if it turns out that it's really good, you can expand later after you've tested the market with actual product. So, right. So there's a market research and test market are different approaches, and so lots of large enterprises will, they'll launch in a small geography and then see if it is likely to succeed outside that small geography. But the answer, ultimately, right, is the value of A. That's what we're asking, right? What is the monetary value of this plan? The plan is the leftmost node, and so the answer to this would be 61.8. So the course page has a worked out example with, it's called Tree. You can download. This has some, you'll want to replace these with your actual numbers, but it has, some examples of the logic. Also, if you're following along, building your own cheat, you should be able to. But yeah, these, again, there's only two types of cells. So, up here, this is a very different tree. So you have G depending on I and J, and H depending on I and J, and then E depends on G and H. So you'll have to do some manual entry for all of these cells because they don't look like the ones down here. But again, it's always between a probability weighted average and a max. And those are just the two ways you do it, and you work from right to left to get to this leftmost node. So that's a worked out example of a decision tree. Best of luck, everyone, and I will talk to you later.